Alrighty. Today we are going to be talking more about transformations of functions. Today specifically we are talking about vertical shifts. So this is where our function is now being moved up or down. So vertically is where it's being moved up or down. Okay, so for numbers 1 through 4, it's asking us to graph the original function and then graph the vertical shift. Okay, so let's go ahead and look at number 1. Okay, so we are given a quadratic function, and I'm going to go ahead and just name it. Okay, the quadratic is where we see that squared, x squared. Okay, so let's go ahead and just graph the parent function. Okay, so I have -2, -1, 0, 1, 2. Okay, I'm choosing these points to plug in for my x and my parent function, and we'll plug them in to see what we get for y. Okay, we've done this a couple times already. So if I have y equals -2 squared, if I replace that x with -2, I'm going to get a +4. Okay, and if I were to keep going, if I then replace it with -1, so -1 squared, well, that's going to give me +1. Okay, and so on and so forth. We know that 0 squared is just 0. Okay, +1 squared, I can just say +1. +2 squared is also +4. Okay, so these become my coordinate points for my parent function. Let's go ahead and put them on our graph. I have -2, +4, -1, +1, 0, 0, +1, sorry, a little mark there, 2, 4. Okay, so that is my parent function, the original function. Okay, well now we see that from the parent function, x squared, now we have x squared minus 3. And last time when we talked about horizontal shifts, we always had like parentheses or it was inside something. Well, now it's on the outside, right? X squared is still by itself, and then think of on the outside, we have this -3. Okay, this is what tells us we're going to be moving 3 units, but are we moving up or down? Okay, last time we had to think about kind of opposite. If it was negative, it was going to the right. Okay, well this time it's pretty straight up, moving up and down. When it's -3, that means it wants us to move all those points down 3 units. Okay, now we don't even need to do a t-chart with this function below. I just need to take these coordinate points and move each of them down 3 units. Okay, so we'll start up here, 1, 2, 3. This guy, 1, 2, 3. That guy, 1, 2, 3. That guy, 1, 2, 3. And my last point, 1, 2, 3. Okay, and now we see that there is my transformed function. It's been moved down 3 units. And that's all we're talking about today, is now moving up and down and how our equations are going to look when we're moving them up and down. Okay, so now let's look at number 2. So I'm given my original parent function, okay, the square root of x. I'm going to do the same thing. In fact, let's go ahead and name it. This is a square root function. Sorry, that's so shaky. I wish I could help that a little bit. Okay, so here's the thing I want to remember with square root. I want to choose numbers that I'm plugging in that will actually make sense, or in other words, are perfect square numbers. 0 is a perfect square number, 1 is a perfect square number, and 4 is a perfect square number, meaning I can square root those numbers and get a whole number answer. For example, if I were to plug in 0, okay, so the square root of 0 is 0. So when I plug in 0, I get out 0. Okay, if I do the same thing for 1, the square root of 1 is also 1. And if I do the square root of 4, this is going to give me 2. Okay, so now those become my coordinate points. So I'm going to go ahead and graph them, 0, 0, 1, 1, and 4, 2. Okay, remember these guys aren't going to go into the negatives, at least with the parent function point. Okay, because you can't square root a negative number. Okay, so there's my parent function. Now I just need to look at my transformed function. and then decide how it wants to be moved. So again, it's this +4 is on the outside, which tells me up or down. Is this going to be up 4, down 4? Well, it's pretty straightforward when it's on the outside. +4 means up 4. Okay, so I'm going to take each one of these coordinate points that I already graphed and just move them up 4 spaces. So this guy, 1, 2, 3, 4. This guy, 1, 2, 3, 4. And that guy, 1, 2, 3, 4. And there we go. There's my transformed function that has now been moved up 4 spaces. Fantastic. All right. Okay. Now I have number 3. So let's go ahead and just start with our parent function. We are going to take it up a notch with this one a little bit. Okay, but we're going to start just with our parent function, do our t-chart. Okay, this guy with those absolute values, that tells us this guy is an absolute value function. Okay, so I'm going to go ahead and just choose our normal inputs, -2, -1, 0, 1, and 2. Okay, let's plug them in and see what we get for y. So remember, absolute value means the distance from 0. So how far is -2 from 0? Well, that's 2 units. So we get a +2. Okay, how far is -1 from 0? That's 1 unit or 1 space, so +1. Okay, how far is 0 from 0? 0 units, it's right on 0. All right. Okay, and same thing, 1 is 1 unit away from 0, 2 is 2 units away. Beautiful, so there are my coordinate points. Let's go ahead and plug these guys in. So I have -2, +2, -1, +1, 0, 0, 1, 1, and 2, 2. Okay, then we connect it. This is what our absolute value graph looks like. Beautiful. Okay, now let's take a look at our transformed function. I've taken it up a notch here because I've actually added 2 transformations. Okay, so let's go ahead and look at the inside. This is a review from last time. Remember, inside of anything, so inside these absolute values means left or right. So this is a review. When we see a +2 on the inside, that means it wants us to go to the left 2. Okay, and this is our new transformation this time on the outside. -1 means up or down. Straight up, negative means down 1. So this time we have 2 transformations. That means we're going to have to take each one of these points that we already graphed and move them to the left 2 and down 1. Okay, so let's go ahead and do that. I'll start all the way over here. So I'm going to go to left 2, 1, 2, and down 1. Same thing here, left 2, down 1. Left 2, down 1. This guy, left 2, down 1. This guy, left 2, down 1. Okay, so 2 transformations. That guy was moved to the left 2 units and down 1 based on the transformed function that it gave us. Awesome. Okay, let's try it again. All right, number 4, our original parent function is giving us x cubed. Okay, so whenever you see that cubed, that tells us this is a cubic function. Okay, let's just go ahead and graph our parent function. Alrighty, so let's see. Let's choose the same 5 that we've been doing. Okay, this gives us a good idea of what this graph looks like. Okay, so a couple things with cubic that we have to remember, and you can do this in a calculator. You're more than welcome to. When I plug in -2 cubed, okay, this is going to give me -8, because remember, this is not -2 times 3. This is saying -2 times -2 times -2. Okay, so when I plug in -2, I get out -8. When I plug in -1, -1 times -1 times -1, I get out -1. Okay, when I plug in 0, 0 times itself 3 times is still just 0. 1 times itself 3 times is still just 1. But then 2 times itself, and I want to write this one out, so positive 2 cubed. Remember, this is not 2 times 3, this is 2 times another 2, which gives us 8. Beautiful. Okay, let's go ahead and graph this guy. So I have -2 down to -8, right there. -1, -1, 0, 0, 1, 1, and 2, +8. Alrighty, so there is my parent function. Now let's go ahead and see how it wants us to move these coordinate points based on the transformed function. So again, I have 2 transformations here. I have something on the inside and something on the outside. Inside tells me left and right. Okay, so -1 on the inside. Okay, think the opposite. So this guy means it wants us to go to the right 1 unit. Outside is up or down, so outside of those parentheses. And this guy, don't have to think opposite, +4 is just up 4. Okay, so let's see what we can do with these coordinate points. Okay, so it wants me to take them to the right 1 and up 4. So let's start with this bottom guy down here. Right 1, 1, up 4. 1, 2, 3, 4. Okay, let's go to our next one. Right 1, 1, up 4. 1, 2, 3, 4. Middle guy, right 1, 1, up 1, 2, 3, 4. This guy, right 1, 1, 2, 3, 4. Okay, and then this very top coordinate point, that's gonna go off our graph, so let's go ahead and just connect these guys and call it good. Because we can see that from our original coordinate points, they have been moved to the right 1 and up 4. Excuse me. Beautiful. Okay, let's turn the page over. Okay, so for numbers 5 through 8, it says write the equation of the function given the transformation. Okay, well we know that in all of our final answers, it's going to be y equals, right? This is how our function starts. Y equals, y equals, and y equals. So I just put all 4 of those guys right now. Okay, well let's go ahead and look at number 5. So it says, let's take it step by step. A quadratic function. Okay, well a quadratic function starts with x squared. Okay, so that's where our quadratic function is coming from. Let's keep reading. That's been shifted down 4 units. Okay, so remember, down and up means on the outside of the parentheses. So we don't have any parentheses here. So we're just gonna take that x squared, down 4 units, simply means -4. We have a quadratic function that's been shifted down 4 units. So therefore our final function or equation, x squared -4. And there's our final equation. Okay, number 6. An absolute value function, okay, let's start there. Absolute value function means the absolute value of x that's been shifted up 3 units. Okay, remember up and down, we do not put on the inside of the absolute value. So this just means we're going to have our absolute value of x. And if it's being shifted up 3 units, don't have to think opposites here. Up 3 is simply +3 on the outside. Okay, so our final answer is going to be the absolute value of x +3. And there's our finished equation. Awesome. Okay, let's look at number 7. So it gives us a square root function. So it starts with a square root function, which tells us the square root of x. Okay, let's keep reading. Ooh, okay, we have 2 transformations here. The first is to the left, 2 units. Okay, so remember, right and left means the inside. So now we have something with the inside of our square root of x. Okay, well, left 2, think opposite. Usually with the left, I'm thinking minus, but if it's opposite, left is +2. But then it also wants us to shift it up 5 units. Okay, up and down is on the outside, and we don't have to think opposites here. Up is just +5. Okay, so then our final equation, we have the square root of x plus 2, and on the outside of that, plus 5. We have our left 2 transformation and up 5 transformation. Awesome job. All right, number 8. A cubic function. So we have a cubic function, which means we start off with x cubed. Okay, let's keep reading. That's been shifted to the right 4 units. Okay, right and left means inside the parentheses. So now I have x cubed, but it's inside my parentheses now. Okay, usually with right 4, I'd be thinking plus 4, but with right and left, it's opposite. So the right is always minus 4. And then it has another transformation of down 2 units. So up and down is on the outside of our parentheses. Down, we don't have to think opposites here. Down is just minus 2. So our final equation, parentheses, x minus 4 cubed minus 2. We have our right 4 transformation and our down 2 transformation. Beautiful. Okay, the last thing you're going to have to do on your assignment is to simply transform some random points in a shape that it's giving you on a graph. Okay, so it's telling us shift it to the right, or 2 units to the right and 3 units down. So that literally means all we're doing is taking each one of these coordinate points that makes up this triangle. It doesn't really matter that it makes up this triangle. And going 2 units to the right, 3 units down. Okay, so I'll start here on the top. 2 units to the right, 1, 2, 3 units down, 1, 2, 3. Okay, I'll go here next. 1, 2 to the right, 1, 2, 3 down. And my last one, 2 units to the right, 1, 2, 3 down. All you gotta do, and your computer will do this automatically for you, is connect those points. And we see the same shape, it's just been moved to the right 2, down 3. Awesome, let's do that one more time. Okay, shifted 5 units to the left and 1 unit up. Take each one of these points, take it to the 5 to the right, or excuse me, 5 to the left and 1 up. Okay, so I have over here, 5 to the left, 1, 2, 3, 4, 5, and 1 up, boom. This guy, 1, 2, 3, 4, 5, 1 up. And my last guy, 1, 2, 3, 4, 5, and 1 up. Connect those points, and you are done. Same shape, it's just been moved to the left and up. And there we go.